All right, so this is the last practice problem on our conservation of energy notes. In this situation, we have a 100 kilogram roller coaster. It's at the top of a hill going 5 meters per second. And we know that at the top of the hill it's 3 meters above the ground. And we want to know how fast is the roller coaster moving when it reaches ground level, right? Well, we know that when things are at the top of a hill and they roll down, they speed up, right? So whatever our velocity is, it's going to be a little faster than what we started out with, but we want to know exactly how much, okay? Well, to figure this out, we're going to apply our conservation of energy, okay? And the conservation of energy just says the total amount of mechanical energy before and after an interaction is always going to be the same. So in other words, whatever our kinetic and potential energy are at any given moment, they're always going to equal the same amount of mechanical energy. So if we can figure out the mechanical energy up here, we could figure out the mechanical energy at the very, very bottom. And we can work our way backwards to figure out, okay, well, what's kinetic energy? And based on that, what's going to be our velocity? All right. So if we want to solve our mechanical energy at the very, very top, we have to find our individuals of potential and kinetic beforehand. So remember our potential and kinetic equations. Okay. Notice that there is a little bit of overlap between them. They both require the mass of our object, whereas potential energy talks about the mass's interaction with a gravitational field and the height above the ground, whereas kinetic energy just deals with how fast this mass is going. Okay? So based on our equations, we can solve for potential energy and we can solve for kinetic energy just by plugging in the values that we had at the very, very top. So if you plug those into your calculator, you should have got a starting potential energy of 3,000 joules and a starting kinetic energy of 1,250 joules. Again, this is everything based on the information we have here, just plugging in the numbers as we see them in the equation. So when we want to find out what's our total mechanical energy, we're just going to add those two energy forms together. Okay? So the total amount of mechanical energy at the start of this interaction, right, 3,000 plus 1,250, gives us a total amount of 4,250 joules of mechanical energy. Now, if this is a conservative interaction, again, this total isn't going to change. So no matter where on our track the cart is, the total mechanical energy is always going to be the same, whether it's at the top, at the bottom, or even in the middle. Okay? And since we want to know how fast is this cart going at the bottom, let's consider our mechanical energy at the bottom as, again, 4,250. Okay? And that's going to equal whatever the potential energy at the bottom is, plus whatever the kinetic energy at the bottom is. Okay? Well, at the very, very bottom of this hill, we know that our height is equal to 0. So that means if our height is equal to 0, then our potential energy has to be 0. Okay? So if we know that the mechanical energy is equal to the kinetic plus potential, and we have the potential, we have the total mechanical, we could solve for our missing kinetic energy. Okay? Kind of like this, right? So we know that 4,250 joules is equal to whatever my kinetic energy is plus my potential. Okay? So if you do some algebra, you know that, well, 0 plus 4,250 is going to give us 4,250. So that means that has to be what our kinetic energy is at the bottom of the hill. Right? So now that we know what our kinetic energy is down here, we can use that to solve for our missing velocity. Okay? We'll use that to solve for our missing velocity. So what we'll do is we will set this whole thing equal to our newfound kinetic energy. Right? Okay? So if the kinetic energy is equal to 4,250 and we're solving for our missing velocity, we do know our mass, so we can actually plug that into our equation and start to work our way backwards. Okay, so I know that my mass is equal to 100 kilograms. Okay, so 4,250 joules is equal to 1/2 times 100 times our velocity squared. Right? And I know that, well, 1/2 times 100 is equal to 50. So again, simplifying this even further still. Now I just have to solve for my final velocity. To do that, I'm going to divide both sides by 50, because I want to get velocity all by itself. Okay? So if we divide both sides by 50, right, 4,250 joules divided by 50 is equal to 85, okay? And because I had to square my velocity value, right, my final velocity squared is equal to 85. To figure out what my final velocity is by itself, we're just going to take the square root of both sides, so we can cancel that out. So the square root of 85 is equal to 9.2 meters per second, right? And that's going to be our final velocity, okay? So just a quick little recap, right? Now that we know our final velocity, we figured that out by, again, knowing what the total mechanical energy was before and after, okay? And once we knew what our total was and we knew what our ending potential was, we could solve for kinetic energy and just work backwards using our kinetic energy equation to solve for our missing velocity or our new velocity. So I hope this was a little bit helpful. Again, if you have any questions, please reach out, and thanks for watching.